In the last lecture we see the sum of the infinite term of a geometric progression. Okay. To find the sum of the infinite term, there is a condition. The geometric progression is in a decreasing order. Okay, that means the common ratio r, the mod r is less than 1. Okay, it is a condition for the sum of the infinite term in a geometric progression. Now in this lecture we see the use of this sum of the geometric progression, sum of the infinite term in a geometric progression. Here express the recurring decimals as a rational number. Okay, you know the recurring decimals, that means after decimal there are the repeated numbers. We can convert this decimal number as a rational number. Okay, here we know that the rational number here, rational number is in the form of the p by q. Okay, here we see a simple example. Here we can take 1 by 2. Okay, see carefully. Here it is a 1 by 2. 1 by 2 we can write 0.5. Here it is a terminating decimal. Okay, here the 1 by 2 answer it is a 0.5, but it is a terminating decimal. Now we have recurring decimal points. Here we can take the 1 by 3. Therefore it is 0.3333 up to measure. That means we can write this. It is a 0.3 bar. It is a recurring decimal. 3 is repeated infinitely. Okay, 3 is repeated infinitely. So here it is a 0.3 bar. It is a recurring decimal and it is a terminating decimal. Okay, here 1 by 2 exactly it is a 0.5, it is a stop there, but it is a 1 by 3, 0.33333 up to infinite time. So we can write this in the form of 0. It is a 3 bar. That means it is a recurring decimal. Now here we have to given it is a recurring decimal. Okay, here 0.3 bar. It is a recurring decimal. Okay, it is a given. Now this recurring decimal converted into the rational number, it is a 1 by 3. Okay, now here we use the formula for the sum of the infinite terms in a geometric progression. Sum of the infinite term. Now which are the infinite terms? Now here it is a 0.33, that means 0.3 bar means it is a 0.3333 up to infinite times. Okay, here this can be written as here 0.3 bar. This can be written as it is a 0.3 plus 0.03 plus 0.003 plus 0.0003 plus and so on up to infinite time. When we adding all the terms we get this. We get this means we get this. It is a recurring decimal converted as a sum of these infinite terms, and here these infinite terms are in a geometric progression. See carefully here. Here the first term it is a 0.3. It is the first term 0.3, and the common ratio r it is 0.03 upon 0.3. Okay, see carefully, and the calculation it is 0.1. And now here mod of r it is mod of 0.1, and which is 0.1 and which is less than 1. Okay, here that means this geometric progression satisfy the condition mod r less than 1, and here first term it is a 0.3. So the sum of the all infinite terms, this sum of the all infinite terms it is a 0.3 bar. It is a recurring decimal. 0.3 bar it is 0.3 plus 0.03 plus 0.003 plus 0.0003 up to infinite time, and all these terms are in a geometric progression with common ratio it is a 0.1. Now we find the sum of the infinite term it is, and therefore it is yes, it is a upon 1 minus r. A upon 1 minus r. In a it is a 0.3 and 1 minus 0.1, it is r, it is a 0.1, and then it is 0.3 upon, it is a 0.9, and that means it is a 3 by 9, and 3 by 9 means 1 by 3. It is a sum of the infinite terms infinite, it is a 0.3, 0.03, 0.003 up to dash dash. Okay, here sum of these infinite terms is 1 by 3, and sum of the all these terms, it is 0.3 bar. That means 0.3 bar, it is 1 by 3. Okay, here yes means 0.3 bar, and yes is equal to 1 by 3. That means 1 by 3 is equal to 0.3 bar. Here 1 by 3 is equal to 0.3 bar. Okay, now here given that our recurring decimal we convert in the rational number. Okay, rational form. It is a recurring decimal. Given that this recurring decimal we converted into this rational number. Okay, and here to convert recurring decimal in the rational number, here we use the sum of the infinite terms of a geometric progression. Using the sum of the infinite terms of the geometric progression, we convert the recurring decimal into rational number. Okay, see carefully this. Now we see some examples in the exercise 4.2.3. Here it is the second example. Express the following recurring decimals as a rational number. Okay. Here the first example 0.7 bar. The second example it is a 2.4 bar. Third example 2.35 bar. Okay, and the fourth example it is 51.02 bar. Okay, now here we take the first example. Here given that it is a 0.7 bar. Okay, 0.7 bar means 0.7777777 up to infinite time. Then this can be written in the form of, it is a 0.7 plus 0.07 plus 0.007 plus 0.0007 and plus and so on up to infinite. Okay, here the addition of the all terms, it is a 0.77777 up to infinite. That means 0.7 bar. It is a recurring decimal. Now this recurring decimal we can convert it into addition of these all infinite terms. See carefully here. This 0.7 bar converted or write in the form of the addition of these infinite terms. And here these infinite terms are in a geometric progression. With first term it is a 0.7 and the common ratio it is a 0.1. That means 0.07 upon 0.7. Now see carefully here. See carefully. This sum is the sum of infinite term infinite terms in geometric progression with a is equal to 0.7 and r is equal to 0.07 upon 0.7, and again the calculation it is a 0.1, that is it is a mod r, mod of 0.1 it is a 0.1 and which is less than 1. Okay, that means it is this satisfy the condition for the sum of the infinite terms in a geometric progression, and therefore see carefully, 0.7 bar is equal to, it is a sum. Okay, and this sum can be written a upon 1 minus r, sum of the infinite terms. Okay, and then the calculation is a, it is a 0.7 upon 1 minus 0.1, that means 0.7 upon 0.9, and then it is 7 by 9. Okay, that means 0.7 bar is a recurring decimal converted into the rational number, that means the 7 by 9. See carefully, 0.7 bar you can write in the form of the 7 by 9. Okay, now we see the second example. In this second example there is a 2.4 bar. See carefully, this 2.4 bar we can write 2 plus 0.4 bar. Okay, here now it is a 2 plus 0.4 bar, recurring decimal is a second term in this. It is a 2 as it is 2, and recurring decimal it is a 0.4. Now we want to find this 0.4. Here we find the 0.7 like that. We find first it is a 0.4 bar as a rational number. Here 0.4 bar we can write 2 plus 0.4. Now here first we find the value of the 0.4 bar is equal to 0.4 plus 0.04 plus 0.004 plus and so on up to infinity. Okay, here like that. Again this sum is a sum of the infinite term in geometric progression. Here this sum is sum of infinite terms in terms of a geometric progression. Okay, with a is equal to 0.4 and r is equal to 0.04 upon 0.4, that means again 0.1. Okay, here 0.1. Now here mod r, that means mod of 0.1 is equal to 0.1 and which is less than 1, that means sum is exist, and therefore this 0.4 bar is equal to, yes, a upon 1 minus r, and then it is a, it is 0.4 upon 1 minus 0.1, that means 0.4 upon 0.9, that is 4 by 9. Here it is a 4 by 9, it is a only 0.4 bar, but we want to find the value of it is 2.4 bar, that is 2 plus 0.4 bar, and therefore 2.4 bar is equal to 2 plus and then it is 2 plus 4 by 9, and 2 plus 4 by 9, it is 18 plus 2, it is a 22 upon 9, and it is the last answer. 2.4 bar, it is a recurring decimal converted as a rational number, that is 22 upon 9. See carefully, same examples. Here we take the 0.7, here it is a 2.4 bar, that means 2 plus 0.4, and again we find the value of 0.4 like the 0.7. Here it is a 0.4, value of the 0.4, it is a 4 by 9, and then 2.4 bar, it is a 2 plus 0.4 bar, and it is a 0.4 bar, it is a recurring decimal, the value of this, and then addition it is. That means 2.4 bar can be written 22 upon 9. Now we see the third example. Here it is a third 2.35 bar. Okay, only 5 is a recurring decimal, and therefore again this can be written as 2.3 plus 0.05 bar. See carefully, it is a 2.3 and it is a 0.05 addition of this two term, this. Okay, now it is a 2.3 and here it is a 0.05, it is a recurring decimal. We converted this recurring decimal is the sum of the infinite terms. Okay, now here 0.05 bar, this can be written 0.05 plus 0.005 plus 0.0005 plus and so on up to infinity. Again here it is a sum of the infinite term in a geometric progression with first term 0.05. Okay, therefore this sum is sum of infinite terms in geometric progression with a is equal to 0.05, that is the first term, and r is equal to, see carefully, it is a 0.005 upon 0.05. Okay, here again it is a 0.1. See carefully the calculation. We take two decimals, then 0.5 upon 5, again it is a 0.1, and that mod r, mod of 0.1, it is a 0.1 which is less than 1. Okay, and therefore this sum here it is 0.05 bar is equal to, that is yes, a upon 1 minus r, and a it is a 0.05 upon 1 minus 0.1, then it is a 0.05 upon 0.9. See carefully, and then it is, here it is a, after decimal point it is 1 digit, and here it is a 2 digits. Okay, now here it is 5 upon 90. Okay, it is 5 upon 90, it is a sum of this term, but we have to 2.35, and therefore 2.35 bar is equal to 2.3 plus 0.05, this term. Here 2.3 is also in the form of the decimal, we can convert it into the rational. So this 2.3 we can write in the form of 23 upon 10 and plus 5 upon 90. Okay, and 5 upon 90, okay, I think it is 1 by 18, we can write 5 upon 19, we can write it is 1 by 18. Okay, here this is 1 by 18. Okay, and now we calculate this. 18 into 23, 18 3s are 54 and 8 into 36 plus, okay, and plus 10 upon here 10 into 18. See carefully the calculation. And now here it is 424 upon 10 into 18, and then 10 and it is 400, you can divide it by 2, therefore it is a 212 upon 5 into 18, again divided by 2, it is 106 upon 5 into 9, here again divided by 2, and then the last answer it is 106 upon it is 45. Okay, here it is 2.35 bar, 2.35 bar, it is 106 upon 45. Okay, see carefully all the calculation. Now we see the last. Here the last, the example number 4, 51.02 bar, see carefully, 51.02 bar. Okay, and then this can be written, it is a 51 plus 0.02. Okay, here now we want to find this sum. It is a 0.02 bar is equal to 0.02 plus 0.002 plus 0.0002 plus and so on up to infinite time. It is a 0.02 bar, it is a 0.02222 up to infinite, and addition of the all terms is also same. Now this sum is a sum of the infinite terms in a geometric progression with a, it is a 0.02, first term 0.02, and common ratio it is a 0.002 upon 02, again it is a 0.1. Okay, same as the last example, that is mod r is less than 1. Okay, mod r is less than 1, therefore we want to find this sum, therefore 0.02 bar is equal to, it is yes a upon 1 minus r, sum of the infinite terms of a geometric progression, and then it is first term it is a 0.02 upon 1 minus 0.1, then it is a 0.02 upon 0.9, and again it is a 2 upon 90. Okay, and 2 upon 90 means 1 by 45, therefore it is 0.02 bar. 0.02 bar is equal to, we can write 2 by 90, that means 1 by 45. It is 1 by 45. Now we want to find the value of 51.02 bar. Therefore we can write 51.02 bar is equal to 51 plus 0.2 bar, and here 0.02. Okay. Now here it is a 51 plus 0.02 bar, it is a 1 by 45. It is 1 by 45. Now calculate this. It is 45 into 51. Okay, here it is a 45 into 1. It is 45. Carry 4. 45 into 5. It is a 225. And carry 4. It is a 229. And this plus 1 upon 45. And then it is 2296 upon 45. It is the value of 51.02 bar. See carefully. That means this recurring decimal converted into the rational number. See carefully all the examples here. The sum of the infinite term in a geometric progression is used in the conversion of recurring decimal into the rational number. Okay, here conversion of recurring decimal into rational number. Okay, here we use the sum of the infinite term in a geometric progression. Okay, see carefully.